To determine whether our statistic is useful, we'll implement a bootstrapping procedure. To do so, we'll first assume that no difference exists between the two conditions. In the language of statistics, this is called the null hypothesis. If this null hypothesis holds, then we can pool all of the EEG signals together from both conditions, for a total of 2,000 trials, and draw from this combined distribution to create resampled ERPs representative of either condition. It may seem strange and counterintuitive to create pseudodata by selecting trials across both conditions. Intuitively, we may expect that the data differs in these two conditions and feel uncomfortable making a pseudo data set that includes trials from both conditions. But under the null hypothesis, we assume no difference between the EEG responses in condition A or condition B, and we're therefore free to create pseudodata drawing from trials in both conditions. That's what we'll do with the goal of creating a distribution of values for our variable stat under the null hypothesis that condition A and condition B exhibit no difference. We will then compare the observed value of stat with this distribution of stat values. If there is a difference between the two conditions, then we expect to find the observed value of stat to be very different from the distribution of stat values generated from the pseudodata under the null hypothesis. Let's now create this distribution of stat values under the null hypothesis of no difference between the two conditions. The idea is very similar to the bootstrapping procedure we've already used to construct the confidence interval for the ERP in condition A. We'll outline this procedure in 6 steps. The first step is to merge the 1,000 trials of EEG data from conditions A and B to form a combined distribution of 2,000 trials. In step 2, we sample with replacement 1,000 trials of EEG data from the combined distribution and compute the resampled ERP. In step 3, we repeat step 2 and compute a second resampled ERP. Next, in step 4, we compute the statistic, the maximum absolute value of the difference between the two resampled ERPs. In step 5, we repeat steps 2 through 4 3,000 times to create a distribution of statistic values. Finally, in step 6, we compare the observed statistic to this distribution of statistic values. If the observed statistic is greater than 95% of the bootstrap values, we reject the null hypothesis that the two conditions are the same. That's a rather long set of instructions to implement this procedure. At this point, you might pause this video and try to digest these instructions. In the next video, we'll implement this procedure in MATLAB, which hopefully will show that it is rather straightforward to compute.